Example 7 is an example of what we were talking about on the previous page. It says determine whether the quantity A union B, the complement of that, is the same thing as, is equal to A complement intersection B complement for all sets A and B. Notice we don't even have to have the elements of the set to make this argument. We are going to make arguments based on regions of a Venn diagram. What area are they talking about? So simply we're going to write equal or not equal, but we must support our answer mathematically. So what I'm going to do is I'm always going to draw the same Venn diagram, the overlapping Venn diagram. I'll label the first circle A, the second circle B, and then remember I'm going to label my regions. 1 is in the middle, 2 is just A, 3 is just B, and 4 is going to be everything else. So what I want to do is consider what areas of the Venn diagram am I talking about for each of these sets, and we're going to make two separate arguments here. Let's look at the first one, which is A union B complement, and then we're going to compare to that the regions of A complement intersection B complement. So let's think about this. A union B complement. Well, just like order of operations, we have to do inside the parentheses first. So A union B is what is in A or B or both? Well, we already decided A union B is regions 1, 2, and 3. All three of those regions, right? But then we need the complement of that. So we need everything that is not in regions 1, not in regions 2, nor in regions 3. It can't be in any of those regions. Well, the only region left over is region 4. So A union B quantity complement is talking about elements in region 4. Okay, let's continue. Let's look at the next one. A complement intersect B complement. Well, let's take a second here to think about what is A complement. A complement is the things not in A. We discussed this on the last page. The things not in A would be regions 3 and regions 4. Those are the regions not in A, right? Cross out A, which is regions 1 and 2. Regions 3 and 4 are left. Now let's look at not in B. Not in B. Well, that's crossing out regions 1 and 3. So what's left? That would be regions 2 and 4. Okay? Remember intersection here. Intersection means what's in common. So what do you see in common between those two things? I see region 4 in common between those two things. So because these two things are the same, that implies these two things are equal. If we got region 4 for the first and we got region 4 for the second one, nothing else, exactly the same, those two things are equal. If on the left we got region 3 and on the right we got region 4, those two things would not be equal. So they're only equal if and only if you're talking about the same regions of the Venn diagram. Let's give this another example here. Let's move on to example 8 to see this again. Again, I'm going to start off with drawing my Venn diagram just because I'm a visual person. I like seeing the regions that I'm talking about. Two circles overlapping with A and B, labeling those regions. 1 is the intersection, 2 is just A, 3 is just B, and then 4 is everything else. And we're going to look at the two things here. We have A intersect B, and then we have the complement of that. And we're going to compare that to A complement union B complement. So let's think about this. First, we're looking at A intersect B complement. What regions does A intersect B complement? Well, let's do inside the parentheses first. Inside the parentheses is A intersect B. A intersect B is just region 1. So we need the complement of region 1. Everything that is not in region 1. Well, what is not region 1? That would be regions 2, regions 3, and region 4. So regions 2, 3, and 4. So A union B, A intersect B, that quantity complement is talking about anything in regions 2, 3, and or 4. Let's move on to the next one. We have A complement union B complement. Again, we already know what A complement is. It's everything not in A, which is regions 3 and 4. We know what B complement is. It's everything not in B, which was regions 2 and 4. But notice now we're doing the union instead of the intersection. The union is everything. Your baggage, my baggage, bring it together, right? So that's everything. So what regions are we talking about? Well, what regions do I see? I see regions 2, regions 3, and regions 4. Okay, so on the first one, we got regions 2, 3, and 4. On the second one, we got 2, 3, and 4. So what does that mean? It means, indeed, these two things are equal. One of these guaranteed is going to be on the test. With two sets, I'm going to say determine whether these are equal or not. And it's going to be really easy on WebAssign to either select that they're equal or not equal. But what I'm purely looking for in this case is, did you show the work? Did you determine the regions of the first one independent of the regions of the second one? And are those two things the same? These two things were the same, and that is the only reason that we could draw the conclusion that they are equal. Okay. What we just proved is De Morgan's laws. A union B complement is A complement intersect B complement. And we also proved that A intersect B complement is equal to A complement union B complement. You negate each part of it. The set and the complement of intersection is union in a sense when you complement everything.